one variable. Starting out on problem number 1, it says that Judy has $12 more than Barb. Together they have $58. How much does each girl have? Well, if we let Barb be equal to B, then that means that Judy must be equal to B plus 12 since she has 12 more dollars than Barb. Together they have $58. So since we've established what our variable stands for, together, so taking Barb plus Judy, they have $58, and I've set up my equation. So 2b plus 12 is equal to 58. Subtract 12. So 2b is equal to 46. So that means that b is equal to 23. Now we're not done with this. Please make sure that you go back and actually answer the questions that they ask. It says, how much money does each girl have? Well, if B stands for Barb, that means that Barb has $23. And then Judy is going to be $12 more than Barb, which would be $35. And you can do some checking with that. Together they have $58. Judy has $12 more than Barb, so my answer checks out. On the second problem, it says the newspaper ad costs $12.50 plus 30 cents for each word after 12. Yolanda paid $12 for an ad. How many words were there? Oftentimes, if you look at the question, that'll help you decide what exactly our variable is. So if I let W be the words in my ad, and Yolanda paid $17 for that ad, so 17 equals. She paid $12.50 for the ad, and it doesn't matter how many words that ad is, it's going to be $12.50, that's a constant, and then plus 30 cents after each word, or after the first 12. So I have W minus 12 because the first 12 are free. So here's my equation. Now I can go through and multiply and get rid of my variables. I could leave my decimals. I could leave my decimals in, but if I go through and get rid of my decimals by multiplying by 10, I have this equation. So 170 is equal to 125 plus 3W minus 36. If I put my 125 and my 36 together, I would end up with 3W. What is that? I'll quickly go through and check that. That would be 89. So 3W plus 89 is equal to 170. Subtract 89 from that. I end up with 81 is equal to 3W. So W is going to be equal to 27. What does W represent? W represents the words in the ad. So my answer is 27 words. And again, you can go through and check that. You can go through and first of all take the first 12, which is 15, multiply it times 0.3, which is 4.5. And if I go through and take 4.5 plus 12.50, I end up with $17. So you can go through and check on word problems. Okay. Going down to problem 3. It says tickets for the demo derby were $8 in advance and $10 at the gate. There are 330 more advance tickets than those sold at the gate. Total sales are $6,420. How many tickets were sold in advance? If we go through and just create a little chart, okay, we have the number times the price each is going to be equal to our total. So if we have advance tickets and we have gate tickets, we can create this little chart to help us create an equation. So advance tickets is the price each, so they are $8 each. The gate tickets are $10 each. Says there are 330 more advance tickets than that was sold at the gate. So if I let G be how many are sold at the gate, then $330 plus G would be equal to those sold in advance. Okay. So here is the total for those sold, the total value for those sold in advance, which would be 8 times G plus 330. Here it would be equal to, I didn't give myself enough room, 10G. Now this is the total for both of them added together. And right there is my cell, 6,420. So if I take 8 times G plus 330 plus 10G is equal to 6,420, I don't have any decimals to worry about. So I can go through and distribute. So if I multiply this, this is 2,640 plus 10G is equal to 6,420. Putting these together, I'd have 18G plus 2,640 is equal to 6,420. Going through and solving, if I go through and take 2,640 and subtract it from 6,420, I have 18G is equal to 3,780. If I go through then and divide, I'm going to end up with 210. So G stands for gate tickets. So I've got 210 at the gate. And then the advance tickets is 210 plus 330, which is 540 advance tickets. And that would be my answer. On problem 4, we have a rate times time is equal to distance problem. And that's going to be the equation that we set up, and we're going to use a chart like we did up on problem 3. Okay. First of all, let's just get a visual. At noon, a cargo plane, so let's say this is McCare's airport right here. It leaves the airport and heads east at 180 miles per hour. Its destination is Jamestown, 500 miles away. Now this actually ends up being useless information, but sometimes problems do throw in some of that useless information. And then at 1 o'clock, so 1 hour later, a jet plane leaves McCare and flies east at, oops, not west, east. And it also too is flying east at 450 miles per hour. So it wants to know at what time do these end up overtaking or actually just being at the same place. Okay, so if I set up my rate times time is equal to distance, and this is the cargo plane, and this is the, what kind of plane is this? The jet. This is the cargo plane is going at 180 miles per hour. says the jet is going at 550 miles per hour. Now the cargo plane left at noon. The jet plane left at 1. So if we let the cargo plane be t, then jet has to be t minus 1 because it is up in the air 1 hour less than the cargo. This t represents time in the air. It doesn't mean noon, 1 o'clock, 2 o'clock, 3 o'clock. It means time up in the air. Okay, so if we multiply across, we have 100t here. And if we multiply across, we have 450 times t minus 1 here. Now these distances, if you go back up here and look, they're flying the same direction. Their distances are actually going to be equal to each other. So that's what we're going to do, is set these equal to each other. So now we go through and solve. If I go through and subtract 450t, I end up with a negative 270t is equal to a negative 450 divided by negative 270, and I end up with 1.66666, or 1 2/3. Now t represents hours. It's amount of time up in the air. So this does not give us our answer because up here it's asked what time, not how long, what time. So if we take this and we plug this into, any one of these. I could take it into the noon, the cargo plane leaving at noon. So we could have 12 o'clock and add 1 2/3 hours. Or we could subtract 1 2/3 minus 1, which is 1. And then we could take that 1 o'clock and just add 2/3 to it. We should end up at the exact same time. So this would be 1:40 p.m., 2/3 of an hour is 40 minutes, or this would also be 1:40 p.m. Okay, since they're both ending up overtaking each other at the same place at the same time, this should end up being the same, regardless of which time you're using. Okay, let's look at example number 5. Example number 5 talks about supplements and complements. Now, supplemental angles are angles that add up to be 180. And complementary angles equal 90 degrees. So if it says the measure of the supplement of the angle is 18 degrees less than 3 times the measure of the complement of the same angle, so we're talking about we have an angle here. Let's say that's x. So the complement would be 90 minus x, and the supplement would be 180 minus x. So this is a complement, and this is a supplement. Okay, so let's just take this one sentence and create an equation. This is the measure of the supplement of the angle, so 180 minus x is 18 degrees less than 3 times the measure of the complement. So it's 3 times the measure of the complement and 18 degrees less than that. Anytime in math you have just a one sentence equation, one sentence problem, you tend to be able just to set it up as an equation the way it's written. So 180 minus x is equal to 270 minus 3x minus 18. 270 minus 18 is 252 minus 3x. If I add the 2x over, that just gives me x. And if I subtract the 1, then I have x is equal to 72. Okay. Again, I can go through and plug this in, but if x is equal to 72, then the complement's going to be 18 degrees, and the supplement would be 180 minus that, which would be 108 degrees. But they're just wanting to know the measure of the angle, so it'd be 72 degrees. Again, if you just have a sentence as for a word problem, see if you can't just use that, set it up, is equal to, okay? And then you can break that up into an equation with the equal to sign right there in the middle. Okay. Example number 6. Example number 6, it says a jar contains 30 coins containing quarters and dimes. The value is $5.70. If you remember back, and I believe it was in problem number 3 where we set up a chart, that's exactly what we're going to do. Because we have two different coins. We have quarters and we have dimes. And we have the value for one times the number is going to give us our total value. So a quarter is worth 25 cents. A dime is worth 10 cents. We have 30 coins to split between these two. So if I let one be Q, then the other must be 30 minus Q. And if I multiply that across, that gives me the total value for that coin. So I have 0.10 times 30 minus Q. And just like in problem number 3, it tells us our total value. So my equation is 0.25 Q plus 0.10 times 30 minus Q is equal to $5.70. I'm going to multiply through by 100. So I have 25Q plus 10 times 30 minus Q is equal to 570. So 25Q plus 300 minus 10Q is equal to 570. 15Q plus 300 is equal to 570. Subtract 300. I have 15Q is equal to 270. Divide through by 15. I have Q is equal to 18. Q represents quarters, so I have 18 quarters. And because I have 30 minus Q for my dimes, I have 18 quarters plus 12 dimes. Now problem number 7 is very similar to problem number 6. Simple interest is if you have principal times rate times time, that is going to be equal to your interest. T is your total time, and in this case it's 1 year. So we really don't have to worry too much about the time element. But the problem says a man invested $6,000, part of it at 5% simple interest and the rest at 7% simple interest. If his annual interest income is $372, how much did he invest at each rate? Okay. So we have two different rates. We have our 5% rate and we have our 7% rate. Principal times rate times time, but time is equal to 1 year, is equal to our interest. Now our interest, $372, doesn't go in here. This interest right here represents what we earned at 5%. This interest right here is what we earned at 7%. This 372 is combined. Okay, so the rate is 5%, 0.05. The rate at 7% is 0.07. And just as up on problem number 6, we had to split 30 coins up between the dimes and the quarters. We're going to have to split 6,000 up between 5% and 7%. Okay? Let's say that I let the principal at 5% be F. Then the principal at 7% must be 6,000 minus F. If I multiply across, I end up with 0.07 times 6,000 minus F. These represent the principal at each. So what I'm going to do is take that 0.05F plus 0.07 times 6,000 minus F. And set it equal to, this represents interest, this represents interest, this represents 372. I can leave these decimals in. I'm going to multiply times 100 to get them out. So I have 5F plus 7 times 6,000 minus F is equal to 37,200. So I have 5F plus 42,000 minus 7F is equal to 37,200. This gives me a negative 2F. And then if I subtract 42,000 over, whoops, I should end up, it's a negative 42,000 minus 37,200. I end up with a negative 4,800. So F is going to be equal to 2,400. F represents percent of 55%. So at 5%, I am in $2,400, and at 7%, I am taking that 6,000 and subtracting 2,400, and I'm getting 3,600, and that would be my answer.